team did this research with HHS Ignite funding is that we're in two businesses. We're in the business of food safety and food defense. In food safety, we have to keep our nation's food supply safe from pathogenic organisms. Also, in light of September 11th, we're in the food defense business now. We never know when a terrorist team can attack and contaminate our foods with disease-causing organisms. Also, FDA regulates $49 billion worth of imported foods. In fiscal year 2012 alone, we imported over 11 million shipments of imports. Of those 11 million that came into the country in 2012, we only examined a little bit over 200,000, or less than 2%. Also, there's a guidance in FDA, which is a rule of thumb, that we can only hold perishable foods for up to 4 days before being released. And that's up to the district. Another thing that could hold back these testing is our conventional microbiological methods. First of all, they're expensive, there's recurrent costs. It requires high volume of sample preparation. We may get false positives. It's labor intensive and time consuming, anywhere between 3 to 5 days. Now, what we're bringing along, which is capillary electrophoresis in mass spectrometry, in our research, in our first phase, we only did the CE portion. And with capillary electrophoresis, it's a one-time expense. You buy the equipment, and it's about $100,000, and we in San Juan have the equipment. This technology is effective in analyzing very small amounts of sample. All you have to do is take an aliquot of the sample, stick it into a vial, and put it into the CE. It's highly efficient. Very little sample preparation is involved. We have fast run times. And this methodology and this technique has been used before in academia to detect bacterial cultures. Here's a diagram, a schematic of how the capillary electrophoresis work. As you see, the molecules or the bacteria go through a thin capillary where light, UV light, is shined upon the molecule, and as it goes by the UV light, you will see these little peaks coming out on the chromatogram on the monitor here. And each peak corresponds to the molecule or to the bacteria. In our research, we utilized these bacteria. We used E. coli, Salmonella, and Staphylococcus. At this point, we have not used any actual food samples. This is the day we discovered, well, not discovered, we were able to isolate the peak, see the peak on our screen. Right there is Dr. Fernando Gonzalez. He very instrumental in this project. And here are our preliminary results. The top screen you see, it's called an electropherogram. That peak you see there is of E. coli. And if you notice, the peak started to elute or come out of the out into the screen at about 8 minutes. The whole runtime took 20 minutes. The peak below is Salmonella. This peak came out around about 3 minutes, and the whole run was about 20 minutes long. So it's very highly efficient at fast run times. Now, comparing conventional methods with CE methods. Like I said before, conventional methods are expensive, recurrent costs, requires high volume sample preparation. It's labor intensive and time consuming. With capillary electrophoresis, it's a one-time expense. We have the equipment. It's effective in analyzing small amounts of sample, highly efficient, minimum sample preparation, and fast run times. Like I said before, E. coli in 20 minutes, Salmonella in about 20 minutes also. Our next steps: use actual food samples, modify and fine-tune methods to identify more organisms. Move on to the mass spectrometry portion, build the mass spectral library, which is also saving costs because we could, instead of using standards, we use actual spectrographs of the bacteria, which we store in an electronic library. Long-term confirmation of results, wide-scale adoption throughout the FDA, speed up regulatory actions. And our goal is to protect the nation's food supply more effectively and more expeditiously. That's the team. Thank you guys. If you're watching, thanks a lot. And here we go. That's our laboratory. This is just the humble beginnings of HHS Ignite funding and support. With this, guys, you gave us our first micro lab in San Juan Laboratory. And from here on in, the sky's the limit. Thank you.
Thank you.
Yes, totally.
Yeah, definitely. So, Mark, I suspect you might have some interesting questions.
Yeah, so what evidence do you have or any that the entire sample was not going to interfere with, the entire food sample might not interfere or be too complex, and will that require some sample preparation before you run it through the capillary electrophoresis?
That's a very good question, because that's one thing I have to reiterate about. Conventional methods take about, when you incubate a bacteria, it takes about 24 hours to incubate the bacteria to get the cultures. But we're looking into research that came from Spain, that they use a certain type of buffer with a medium in it, and we'll take whatever food sample is, for example, produce, put it in these stomacher bags, fill it with buffer, give it a 7-hour wash, which will amplify the number of bacteria in there. Okay, so we would take an aliquot of this sample, put it into the CE, and then in the next phase with the mass spectrometer, in the CE, we would see the entire bacteria go by. Since we already have a standard of that bacteria, we would be able to identify the peak. From there on in, it would go from the CE into the mass spec immediately, and the mass spec would break up these bacteria into its component lipids and proteins, and we would see a pattern, and the mass spec would be much more of a confirmatory results. So we would have our results, if it's a 7-hour wash, plus maybe 20 to 40 minutes in between the CE and the MS, maybe in a day we get a result, maybe a day or two, which is much more quicker than 4 days.
So you said in the conventional method it took you 3 to 5 days.
That's the average, 3 to 5 days.
But you can only hold perishable products
Up to
for
4 days, yes.
So as you continue to apply this to the food, does this mean you can release things more quickly?
Absolutely.
Or you can do more surveillance by moving to the CE method?
Absolutely.
How does it help my bananas get here faster?
Absolutely. This will speed up regulatory actions. If we could get the answer within a day or two, we could get that import off the docks into commerce. But if it's contaminated, we could take action immediately.
Definitely. I mean, one thing I should want, is there a plan to share not necessarily the raw data that you're finding, but maybe the signals and the origin of where the food maybe came from publicly?
Could you, I didn't get the question.
So the salmonella signal or
Right.
the E. coli signal, is there a plan maybe to can share that publicly along with the source where the contaminated food came from?
Oh, absolutely.
And what's your plan?
We plan to publish these findings as soon as if we get the funding and the support.
That'd be great.
How long does it, with current technology, with nucleic acid hybridization chips, how long does it take to do that versus this technology? Do you know?
I'm not familiar with that technology, so I really couldn't explore it, really answer that question.
Okay.
So.